sure it does that. We still continue to engage in customs involving holidays and festivals all over the world, all kinds of different things that we celebrate that aren't of really very much importance. Um, Certain cultures continue to engage in what we call puberty rites, bar
Our
mitzvahs,
target,
bat
but in
mitzvahs.
MS control, it's very far from the target. And you may see the same results for 32 seconds and 58 seconds. And the difference between MS and the healthy control people was significant.
Okay, thank you.
Just say a few words.
That's it. Thank you so much for joining us. That's what I'm saying.
Thank you.
With that, now we are moving on to the next session that is by Elias Iran Khan and Iman Bagari from Kairan Institute of Higher Education, and they're going to speak on early diagnosis of epilepsy with the help of analysis and processing of MRI, images and brain signals. So I'm sharing the screen, Elisi and Iman. You can start your session.
And methods such as surgery, medication, and electrode implants are used to treat the disease. But there is one important truth about it that the origin of epilepsy is still unknown, as mentioned before. In order to diagnose epilepsy early, a combination of image processing and brain signal analysis can be helpful and beneficial. There is an important question about what does an EEG test do? In general, an electroencephalogram EEG records activity in the brain. Your brain constantly produces tiny electrical signals. During the EEG test, small sensors called electrodes are placed on your scalp. The electrodes are connected by wires to an EEG recorder. Electrodes are attached using a special paste glue. After the electrodes are removed, you may still have a lot of glue in your hair. And hair conditioner can help to remove the glue afterwards. And they only pick up the electrical signals. They don't interfere with your brain, and they don't cause you any pain. So the next question: what information does only have unusual electrical activity in their brain when they are having a seizure? The rest of the time in brain activity may be entirely normal. So if your EEG test doesn't show any unusual activity, it only means that there is no epileptic activity in your brain at the time the test is being done. This doesn't prove that you don't have abnormal activity in your brain at others, and it doesn't exclude you having epilepsy. People with some type of epilepsy have unusual electrical activity in their brain even when they are not having a seizure. When they have an EEG test, the results can show certain brain. My dear co-author Iman is here, and he will be continued this presentation. And thank you so much.
Okay, thank you for dedicating the time, and I really say warm hello to the professors. So regarding the methods in diagnosis of the epilepsy, optimal processing of the optimal EEG brain signals, that it's a kind of combination between the image processing on the MRI and the signal processing on EEG signal, electroencephalogram signals. What we are going to perform is important, of course, a severe scattered. So this is also indicated in our previous mentioning. So going to the next slide, please. So this is another important feature that we're going to describe here, the return map. So the aim of return map is to find a hitting point, of course, showing the similarity to the current, previous, and the next samples of the EEG. And using the return map, we can actually have some shape features, such as how periodic is the signal. Is it, for example, non-periodic or semi-periodic or even chaotic? And parameters like trajectory of the system in state space, and of course quizzing points that are important, of course indicating that how the system works by analyzing the return map. As you see in the right side, we have two figures that one of them is indicating actually a visualization on a line between a normal and mild and the severe according to our data that we performed in our research. The 2D visualization interpretation shows that the samples on the line and the longer distance is, the less chances of epilepsy is going to happen. And centralized and circularized in the phase figure that we have in 3D in the right and the downside, we have the blue actually curves that we see that they're circularizing and going to the center. Deep in the details of the centers, as we go deep into the centers, we have more similarities found in the return map, which increase the chances of epilepsy in the people. So among this part, we finished actually the signal processing, and then we're a little bit focusing on image processing, and then coming back to compare both of them. So regarding the image processing of MRI images, we have the binarization of the image that can create a kind of thresholding the image that the gray values will be converted to 0 and 1 and to black and very light, very white. And then we have the noise reduction filter that can be very useful. As you see, the right photo has some noises. Noises are defined and the multi-layer perceptron that we performed for the EEG signal processing and the MRI image processing for MRI images. We're using neural network architectures. So generally deep inside.
Thank you. Thank you so much for both of you. So I request other speakers have any questions to Iman and Alice, they can ask now.
I have a couple of questions and an idea. So let me start with what I think is less important. That's your statistical analysis, because at the end of the day, it's the big idea that's more important than the stats. So your analysis was based on FFT?
No, it was not based on FFT. It has frequency, but it is not fast Fourier transform. Definitely not indicating the fast Fourier transform that you are mentioning right now.
No, because you didn't say that. And if
you talked about FFT, I know.
I would have given you a whole thing about Hilbert transforms, but
okay, sure.
I don't want to get into that. The second thing is you have a model. It's a two-layer model.
It's a kind of it has more than the most important thing is the first layer and the last layer, but there are some hidden layers between.
Yeah, because the brain is more than that.
Yeah, of course.
The third thing, and these are the technical questions, then I have something which is a suggestion on top of that. The third thing is your stats are based on median mode, median mode and
range, you mean?
What was it?
Yeah, mean,
right.
mean and median mode, yeah.
What did you do about
mode as a definition of the mode? Yeah, I'm going to answer. Is your question finished?
No, I was going to say, what are you doing about the homogeneity of variance? Is it homogeneous? Is it heterogeneous? In other words, these are multiple factors in there. So is descriptive statistics the best way of getting into it?
Yeah, of course. That's homogeneous. Yeah, and yeah, of course, these are really important to be noticed. Yeah, and to be considered, of course. What we performed regarding the fact that why we are using the mode that has the most significant effect here is just by the definition of the mode. So what is the meaning of mode? When we compare it back to for example, the median means to select the middle signal. When it comes to mode, it means the frequency of happening. So what is important in the epilepsy, what matters to us is how frequent it happens, in terms of signals, and how scattering is in terms of line or the phase on the phase map, that how centralized are them. So what matters, the most important feature here is mode and the repetition of these things. When they are repeated too often, and they are centralized, or maybe in a line that are just in terms of dots that we receive in terms of signals, it shows that we have epilepsy. But as they are scattered and they are chaotic, it shows that the person that is experiencing not epilepsy, or maybe very mild epilepsy. That's why we perform this.
Now the presence of it. Now my point.
Yeah.
So now that you know what epileptic activity is, you now have a binary algorithm, which is it there, is it not? And who cares from which leads? Your object is to make a frontal lobe decision to turn it off.
Yeah, exactly. And we're performing accuracy about that, and which is not just limited to 0 and 1. I mean, the binary, just to dedicating the fact that whether someone has epilepsy or not, we're calculating and predicting and anticipating the fact that how prone he is to have epilepsy. That's what we perform.
This is the next step. What you've got in your hands, I believe, at least as I understood it,
Yeah, thank you very much.
is the decision of you don't have it. That's more important than you have it.
Yeah, exactly. Yeah, this
Because
is
that
important. Yeah,
allows you
because
to
that
hook up.
person could be clarified about it. That okay, thanks God that I don't have epilepsy, and I don't have any chance in the future that I become, I don't know, prone to epilepsy or experiencing this. This is what we actually, our team actually performed.
It's a potential great contribution
Thank you.
to do that.
Thank you very much.
Okay.
Thank you so much.
Well,
Is there any other question that you would like to ask, or any other members that would like to ask?